Hello and welcome to AJEE. Today we have a few special guests, Dr. Stormy, Professor Precipitation, and the well-known Dr. Air. Our first guest is Dr. Stormy.
Hello.
Hello, Dr. Stormy. So I was wondering if you could tell us how thunderstorms form.
Sure, well, there are three conditions for formation. The first condition of formation is lots of moisture in the lower part of the atmosphere.
Oh, I see. So there has to be lots of moisture on the lower part of the atmosphere?
Yes.
So tell us about the second condition for formation.
Okay, well, the second condition for formation is that the air must be lifted so that moisture can release and then condense latent heat.
That's very interesting. I never knew that the air must be lifted so that the moisture can release and condense latent heat. So tell us about the third formation.
Well, the third condition for formation is the portion of the atmosphere where the clouds grow must be unstable.
That's very cool. So the portion of the atmosphere where the clouds grow must be unstable.
Yes.
Well, thank you for being our guest today, Dr. Stormy.
You're very welcome.
Next, we have another person here to talk about the stages of development for thunderstorms. Please welcome Professor Precipitation.
Hello?
Hello, Professor Precipitation. So what are the stages of development?
That's easy. There are three stages of development. The first stage of development is the cumulus stage. The cumulus stage starts with updraft. The moisture is transported by updrafts, then it condenses into droplets.
Wow, really? I never knew that the moisture is transported by updrafts, then it condenses into droplets. So what are the other two stages of development all about?
Well, the second stage of development is the mature stage. In the mature stage, precipitation cools and then condenses the air. Then the air sinks to the ground. The third stage of development is the dissipation stage. In the dissipation stage, downdrafts create thunderstorms. The updrafts stop when the convection cell ends. The warm, moist air runs out and the areas near the storm cool.
Very interesting. I didn't know about the dissipation stage. Can you tell me a little more about it?
The updraft ceases when the warm air runs out. The storm stops when the raindrops are gone.
Okay, well, thank you for telling us about the stages of development, Professor Precipitation.
No problem.
Now we have our final guest, and she will be telling us about air mass thunderstorms and frontal thunderstorms. So please welcome Dr. Air.
Hello.
Hello, Dr. Air. So what can you tell us about air mass thunderstorms and frontal thunderstorms?
Well, I can tell you that mountain thunderstorms occur when an air mass rises as a result of orographic lifting.
Oh, mass rises as a result of orographic lifting. So what else can you tell us about air mass thunderstorms?
I can also tell you that sea breeze thunderstorms are local air mass thunderstorms caused in part by extreme temperatures. There are differences between the air over water and the air over land.
I see. So let's move on to frontal thunderstorms. What can you tell us about them?
Frontal thunderstorms are produced by advanced cold fronts and rarely warm fronts.
Is there anything else about frontal thunderstorms?
Well, the rapid upward motion in cold fronts can produce a line of thunderstorms. The storm gets the initial lift from a push of cold air.
I see. Go on.
In a warm front, the boundary between two air masses is not steep, so air rises gradually. If the warm air behind the warm front is unstable and moisture levels are high, mild thunderstorms can develop.
Wow, mild thunderstorms can develop when that happens. Okay, well, thank you for explaining to us about the air mass thunderstorms and frontal thunderstorms.
You're welcome.
I think that's all the time we have today. Join us next time on AJEE. Bye.